Welcome to the Potter Electric video on detector status reports. Potter's Detector Status Report is NFPA compliant for sensitivity testing and can be used as a part of test and inspection documentation. It also provides useful information regarding the current health of the fire alarm system. To retrieve a copy of the Detector Status Report, you will need the Potter Fire Panel programming software and will use the detector status icon shown here. Connect to the panel using the panel's IP address and remote access username and password in the same manner that would be used to send or retrieve a panel's configuration file. Once the report is retrieved, it can be exported as either a Word document or an Excel spreadsheet. The individual detectors are shown in rows, with the specific data for those detectors being shown in columns. The far left column is the device's address, which in this case is 00:001. The 00 prefix is indicative of which SLC loop the device is on, with 00 being the built-in loop. The numbers after the colon are the device address on that loop, in this case address 1. The next column displays the sensor type. This will tell you what kind of detector is in that row, as well as if that detector is on an intelligent base, such as a sounder base or a relay base. Input modules or circuits will not be displayed in this report. After that, the detector's custom description is displayed. The first group of device data columns we see are for photoelectric smoke detectors. These cells will be populated with smoke detector information from PAD PD smoke detectors, or the smoke detector elements of detectors that have multiple elements, such as PAD PHDs. Within the smoke detector group, first shown is the current percentage of obscuration that smoke detector was sensing at the time the report was generated. Next is the peak value. Peak values are held on the detectors themselves and are good for the duration of that detector being powered up. Removing the detector from its base, powering down the SLC, sending a new configuration to the control panel, or the control panel fully losing power, will reset the peak values of all detectors on the system. Potter addressable smoke detectors can have their sensitivity turned up based on a schedule. The sensitivity range is 3.5% obscuration up to 1.1%, with 1.1% being notably more sensitive. 3.5% is the default and industry standard. The set points for alarm conditions in day or night mode are shown here. If there is no sensitivity schedule, day sensitivity reflects the smoke detector's alarm set point. NFPA 72 states in Chapter 14, Table 14.4.3.2, Section 17.8, under smoke detector sensitivity testing, in other than 1 and 2 family dwellings, quote, perform any of the following tests to ensure that each smoke detector is within its listed and marked sensitivity range. Option 4 states smoke detector control unit arrangement, whereby the detector causes a signal at the control unit when its sensitivity is outside its listed sensitivity range and is acceptable. The photo drift cell shows the current level of drift for the smoke detector. Potter addressable smoke detectors can compensate for dirt or dust, while the performance is not altered. The drift limit is shown in the next column. That compensation cannot exceed up to 50% of their alarm set point without enunciating a dirty detector trouble. The photo drift alert cell clearly states if the detector is currently in a dirty detector state, while the NFPA compliance cell shows if the detector passes the overall sensitivity test. The next group of device data columns we see are for heat detectors. These cells will be populated with heat detector information from PAD HD heat detectors or the heat detector elements of multi-element detectors. The first column in this group shows the temperature at the time the detector status report was generated. Next is the highest temperature this heat detector has recorded during its current power cycle. The next column shows the high temperature alarm set point for this detector. Potter heat detectors can not only track upwardly mobile temperatures to generate alarm or supervisory conditions, they can also track dropping temperatures for trouble or supervisory signaling. If a heat detector is monitoring for low temperatures, 40 degrees is the default value. Next shows the lowest temperature recorded by the detector. The last column in this group is the rate of rise peak, which shows the highest rate of rise recorded by the detector. The next group of device data columns we see are for carbon monoxide detectors. These cells will be populated with CO detector information from PAD CD carbon monoxide detectors or the CO detector elements of PCDs or PCHDs. The first column in this group shows the carbon monoxide level measured in parts per million at the time the detector status report was generated. Next is the highest carbon monoxide levels this CO detector has recorded during its current power cycle. Carbon monoxide alarms are not based on current levels of CO, but instead on CO sustained over time. Potter carbon monoxide detectors have 3 alarm timers. The first is 70 parts per million sustained over 2 hours. The second timer is 150 ppm continuously detected over 30 minutes. And the third is 400 ppm continuous over 10 minutes. These timers are indicative of a detector currently in a timer sequence. If the detector is currently involved in a 400 parts per million timing, it would be expected to have a larger interval in the 150 ppm timer and an even larger one in the 70. There are peak timers for each of these set points that show the longest the detector has detected CO at each of the mentioned levels. The CO life remaining column tells the amount of runtime a Potter CO detector has remaining. The last group of columns are more administrative in nature. Sensor runtime shows the total time the detector in question has been powered up. The runtime is based on power up time, so if the detector is powered down, that downtime does not detract from the total life remaining. CO detectors are the only Potter detectors that reflect life remaining. The next column shows what protocol the detectors are using. Next to that is which SLC loop the detector resides on. Finally, PAD 300 detectors have a digital date code embedded on the detector, as do the sounder and relay bases. For more information about Potter products, please visit our website at pottersignal.com. To access additional training resources, check out our online training portal at academy.pottersignal.com. Stay connected with us on social media for the latest updates and news.